Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children, we have already completed algebraic expression chapter. So now we are going to start a new chapter, linear equation in one variable. Okay. So I hope you have all completed your algebraic expression notes. So now let's start this chapter, linear equation in one variable. So we'll start with the algebraic expression, okay? What an algebraic expression looks like. We're already familiar with these kind of expression, right? See the one inside this yellow circle, I have written 3x plus y square. So this is one of the algebraic expressions, example of algebraic expression, right? 5x cube plus 2x, this is also an algebraic expression. Then 6x plus y, this is also an algebraic expression, right? We have few numbers or we have variables, right? And we have a power on the variables, like here you have square, here you have 3 cube, that is here you don't have any power, that means there is a 1, and so on, right? So we have different kinds of algebraic expression. Now from this we are going to see what is a linear expression. See the power, the variable whose power is 1 is called as a linear expression. Like, you know, the maximum power the variable should have is supposed to be just 1. See now in this case, the one inside the orange circle, this has got a variable x and y. Two variables are there and both of them are having 1 as the power, right? So this is an example of a linear expression. But look at this, the first one over here, the x over here has got 1 but the y over here has got 2. So there is one of the variables which has got more than 1 as a power, right? So this is not called as a linear equation, okay? You will learn in higher classes what this particular expression is called. So now I'm not going to touch those things, okay? But you know, you have names for each and every expressions with different kinds of power, okay? Different numbers as exponents, you have different names for the equation, okay, or an expression. So now this is not a linear expression, okay? So linear expression is the one which has got 1 as a highest power, okay? You don't have anything greater than 1. So now the second case over here, the x has got 1 but here the x has got 3, right? So again, you know, it's not a case of a linear expression, okay? So in the 3 examples which I have given, this one when the side the orange circle is the only example of linear expression, okay? Now we'll come to this one, examples of linear equation. So now when I say expression, I get only this, okay? Expression has only a number, a variable and a plus or minus sign, that's it, okay? You don't have anything more than that. You have an algebraic operations, that is, you know, positive sign, negative sign, or a multiplication or a division, and you have a number and a few alphabets which are called as variables involved, that's it, okay? But if you have a is equal to sign involved, like in this case, see, you have a is equal to sign over here, so then it's called as a equation, okay? So now you look at the power of the x. See, there is only one variable over here, right? There's only x over here, we don't have any other variables. So this is an equation of linear equation in one variable, okay? That is, so it just says that, that's what the chapter name says, linear equation in one variable. That means you have only one variable over there, you don't have y or z. Like in the previous cases I have given different variables, right? See, look at this, we have got different examples. So in this one, the orange circle, the linear expression, I have actually had a linear expression in 2 variables, x and y are 2 variables. But now in this chapter we are going to learn only linear equation in one variable, and we are going to learn equation, not expression, okay? Equation means you will have a is equal to sign over here, okay? So this equality sign is what tells you that it's an equation. Now over here, see this side of the is equal to sign, see I have written LHS, this means it's left hand side. See, this is towards your left side, right? Left hand, right? So that's why it's called as left hand side, and towards this side you have got right hand side, okay? This side is called as RHS in short, and this is called as LHS on short, okay? Now 5x plus 2 is equals to 12 is what is my equation given to you. I mean, you know, the example which I have given you. So the 12 is the RHS, the LHS is 5x plus 2. In this, the x is what is called as the variable, okay? And 5 is called as the coefficient of x. Okay, so this we have already learned in algebraic expression. Okay, this is just a brush up. All right, now we'll move on to this. So this is an example of linear equation in one variable, that is one unknown value. So when I say one variable, that means there is only one term which is not known to us. Okay, only one alphabet involved over there, that's it. Okay, all right, so now let's come to the next thing. So how are we going to solve linear equation? So we are going to start with the simple ones. Okay, so let me say that I have been given this example. Let's say the example is 3x minus 7 is equals to 5. All right, this is the expression. So now when they ask me to solve, usually this is what the question will be like, in your test and all, they'll say solve. Okay, so what they mean by solve is they are asking you to find the value of an unknown variable. Okay, so in this case, in 3x minus 7 is equals to 5, you don't know what is x, right? X is the only one which you don't know. Rest all you people know, right? So 3 is 3, 7 is 7, 5 is 5. You can't change those. But x is the only one which we don't know, and we need to find out what is there in place of x. Okay, so we are going to, so when they say solve, they are actually asking us to find the value of x. Okay, so whenever, not only in this chapter, anywhere in your, even in your future, when you see any question which says solve, you are actually going to look for the alphabet over there, the unknown variable over there, and you're going to find that. Okay, so now how do we solve this? You will first isolate the x. Isolate x means you will make the x term alone over one side. You will move everything else to the other side. Okay, so I'm going to explain two ways over here. Okay, so see, this is just like, what is actually happening, what we are doing. We're going to look at that. So if you have 3x minus 7 is equals to 5, I will have to first move the 7 to the other side. Okay, so the 7 has to become 0 actually. Understood? When I want to make the 7 to become 0, what will I do? I have minus 7 already. I can just add 7, right? If I add 7, 7 minus 7 becomes 0. But I can't just add 7 on one side of the equation. So I will, whatever I do it on both the sides. Okay. So what do? I add 7 on both the sides. Okay. When I do that, this gets cancelled and I get 0 over here. And I am left with just 3x. See, I get 3x plus 0 is equals to, now the 7 gets added with the 5 over here, because we are adding 7 on both the sides, right? The 7 will get added with the 5 also, and I will get 12 over here. Okay, so now 3x plus 0 is simply 3x. Now I need to get rid of the 3 over here. This 3 which is over here, I need to get rid of this 3. So what do? This 3 and x are multiplied. So I can't make it 0, right? Because if I make it 0, the x will also become 0. If I do minus 3x on both the side, the whole thing will become 0. Then x will also vanish. What is the use of, how can you find the x, right? So what do? We cancel the x by, cancel the 3 by dividing 3 on both the sides. Okay. So when you do that, see, I have divided 3 on both the sides. So the 3 and 3 gets cancelled, and you simply get x is equals to 12 over 3. See, I can write x is equals to 12 over 3. This can be simplified as 3 times 4 is 12. So x is equals to 4. So this is what is actually, this is what is the real way of solving it. Okay, but we can do it in another way also. So I'll tell you how to do that. So usually this is how we do it over here. So this second way, just look at this. Okay, so to follow this, okay, this is more simpler, but you need to know certain rules over here. Okay, so the first rule over here is, do you see it? I have written two kinds of boxes over here. Two boxes I have drawn, right? See, when I move a minus sign to the other side of a is equals to sign, it will turn out to be plus. Okay, and if it is a plus sign, it will turn out to be a minus sign. And if it's multiplication, it will become division, and division turns out to be multiplication. Now the question is, with what it should be, minus, plus, or multiplication, division? Where? How do I look at it? So I should see, if I'm moving a number, okay, I should see that particular number is, how is that particular number attached with the x over there. Okay, so like in this case, you have 3x minus 7, right? So now if you look at this, the x and 7 are attached with the minus sign, right? So we have to look at the sign with which it is attached to the x actually. Okay, so x and 7 are attached to the attached to each other with the subtraction sign. So you move the 7 to the other side. When you do that, the minus will become plus. If it was plus, it would have become minus. Okay, so you have 3x as it is. The 7 goes that side and it gets added up to 5. Okay, now you get 3x is equals to 5 plus 7 is 12. Now you have to move the 3. Now you should see what kind of a relation 3 and x have. So there is no relation written over there, right? There is no symbol written over there. And we know that when there is no symbol written over there, it means that there is a multiplication sign, right? So the 3 will get, when the 3 goes to the other side, it will get divided. See, I have written the third point over here. Multiplication becomes division. So the 3 goes down. This is what is division, right? You can just write it down. So 12 divided by 3. Now you simplify. 3 ones are 3, 3 fours are 12. So you get 4 by 1, which could be simply written as 4. Okay, so this is how we do it over here. I mean, usually this is how we do it, instead of doing the addition. But, the previous method, what I told, that's the logic behind it, okay? But you can just follow this. Anyways, whichever you find comfortable, you can do it in your test, okay? You're going to get the same answer anyways. All right. So if you want to follow the second method, you have to know the rule, okay? Minus turns out to be plus, plus turns out to be minus, multiplication becomes division, and division becomes multiplication. Okay, so now we'll do one more example. So I'm going to follow the second way. Okay, so if you have something like this, 5y plus 4 equals 29. Okay, so what will I do? First I'll move. See, first of all, you should always move the numbers attached to the y with the plus and minus sign. Okay, you can't just first move the 5. You should never do that. You can't move the 5 first, because 5 and y are multiplied with each other. They are more strongly attached. Okay, you can't just break them first. You will have to break this. You'll have to move this. Okay, so 5y is equals to, so when 4 goes to the other side, you will actually get this plus 4. So when it goes this side, it becomes minus 4. So you get 29 minus 4. Okay, and now you get 29 minus 4 is 25. Now you get 5y, so the 5 goes to the other side. When it goes down, to the other side, it goes down, right? It's division. So 25 divided by 5. So again you get 5 5s are 25. At the bottom you don't have anything. You just have 1. You don't have to write that. Okay, so y is equals to 5. Understood? Now we'll move on to the next example. So now when you have a rational number like this, okay, so here in this case I haven't given x or y, I have given a. So if you have a by 2 plus 3 by 4 is equals to minus 1 by 4. So I'm going to again move the terms attached to the a. So first let's move the 3 by 4 to the other side. So there is a plus sign over here. So I will move it to the other side. When it moves, when it goes that side, it becomes minus, right? So see, the minus 1 by 4, which is already here, this will have minus 1 by 4. This will remain as it is, okay? Because we are not changing the sign of the position of minus 1 by 4, right? So this will remain as it is. Now the 3 by 4 becomes minus 3 by 4. Now what do we do? See, now you look at this side. The 4 and 4 are same in the denominators. When you have the same denominators, you can simply write it as a common denominator. So 4 turns out to be a common denominator. Okay, you don't have to write it twice. All right. Okay. Now on the top numerator, you can just simply write it as minus 1 and minus 3. Okay, so when you have minus minus, you are going to add this, right? So adding this is going to give you minus 1 minus 3 is going to give you minus 4. Minus 4 divided by 4. So be careful of the negative sign. You should have a negative sign over here. So this side, on the left side, on the LHS side, you have a by 2 as it is. It's following, right? So you get a by 2 is equals to minus 4 by 4. So when you have 4 by 4, you can just simplify this. 4 ones are 4 ones are. So you actually get negative 1 over 1, which will be just written as negative 1 or minus 1. Okay. So a by 2 equals to minus 1. Now I need to find this a. So I have to move the 2 over here. Now what is the relation between the a and the 2? It's division, right? So the relation between these two is division. When it is divided by, so it's a by 2 or a divided by 2. So when you move the 2 to the other side, it will turn out to be as a multiplication, correct? When it goes to the other side, it will get multiplied. So you get a is equals to minus 1 into 2, which is equals to a equals to minus 2. So that's how you have got this. Okay. So now we'll look at another example. Example 4. Okay. So if you have something like this, 5y over 3 minus 2 is equals to 8. So again what we'll do, we'll first break the minus sign, right? So when it goes to the other side, it turns out to be a plus sign. So you get 8 plus 2. 5y over 3 remains as it is, okay? Now 5y over 3 is equals to 8 plus 2 is 10. Okay, so now we will move. See, you have got 5y over 3 equals to 10. Let's move the 3 first, okay? You can actually move anything first, okay? You can move the 5 or 3. It doesn't matter, okay? So I have just chosen to move the 3 first. So when I move the 3 first, see, this is a division involved over here. So when I go to the other side, it turns out to be multiplication. See, so I get 10 into 2. Now 10 into 3, sorry, 10 into 3. Now I will avoid multiplying this because, I will see if it gets simplified. You should not, if you do 10 into 3 as 30, this will give you an answer, but you avoid doing it, okay? Do all the multiplication at the end, okay? Now you have got y is equals to 10 into 3. Now the 5 has to come down because it's multiplied over here. So when it comes to the other side, it becomes division. So 5 is divided, okay? So 10 into 3 divided by 5. Now you see 5 and 10 could be simplified. 5 2s are 10. So you get 2 into 3 by 1. Right? So that gives you 6. See, if you multiply over here also, you get 5y is equals to 30 and y is equals to 30 over 5, which is 6. So you are going to anyways get the same answer, but this is the best method to do it, okay? Because now this was a very simple thing. 10 into 3 is 30, everyone knows it. But what if you had a bigger multiplication number where we don't remember the tables, like it could be something really big, like if I give you 87 into 53, you won't be able to multiply it, right? So you should not waste time sitting and multiplying that, okay? So instead you should actually keep it and simplify it, okay? You just see whatever is possible, you cut it, and that is called as simplification, okay? Simplify it, and then whatever is left out after simplification, you multiply only those and give the answer. Understood? So I have covered all the kinds of questions which is required for your exercise 3.1. So hope you will be able to do homework as the exercise 3.1 as your homework from the PDF in your classwork. Okay. So now and whatever examples I have given over here, you don't have to copy that in your notebook. Just directly copy down the exercise. Okay. Write the chapter name and start copying your exercise 3.1. Okay. All right. So inshallah I'll see you with the next video. We'll proceed with the next exercise. Okay. Allah Hafiz. Thank you.